Hey physicists, today we want to talk a little bit about momentum. So I want to run through some concepts for you and then work through these two sample problems. So when we look at momentum, Sir Isaac Newton came up with his second law where we would say F equals ma. And he thought, there's something more to the motion of an object than just its velocity. And the way you could think through this is, let's say that I throw a beach ball at you going 10 miles an hour, and I throw a bowling ball at you going 10 miles an hour. Which one would you rather try and catch? Well, I would hope you would say the beach ball, because even though they're both going the same velocity, one of them has a lot less mass, and there's a greater chance that you can change its motion. So this quantity of motion he starts playing around with and says, okay, here I have my mass is equal to acceleration. Mass times acceleration equals force. Remember that our acceleration is really the change in velocity over the change in time, which is going to be our final velocity minus our initial velocity over the time that we have. If we take and we plug that in for our a value over here, then we can say F equals m times Vf minus Vi over t. And then simplify that. So I'm going to multiply both sides by t. I get force times time on one side, and then I'm going to distribute my m. I'm going to get mass times velocity minus mass times velocity on the other. And here's a way then that Sir Isaac Newton could say, hey, look at this. This side has a quantity of motion that we are going to call momentum. So momentum is going to be a mass times a velocity, and it's going to be what we call the quantity of motion, or the amount of motion. Sometimes you'll also see it or hear it as inertia in motion, because remember, mass is really inertia and your motion would be the velocity. Then on the other side, we're left looking at that saying, hey, well, what is a force times a time? And that is what we would call an impulse. So impulse is the amount of force acting on an object for a certain amount of time. So I can take and extend this equation and say, well, this side of the equation is equal to impulse. This side of the equation is equal to the change in momentum. And I end up with one big equation for this chapter that is, when I'm looking at one object, how is the object's momentum going to change if there's an impulse that's acting on that one object? And that's really the key concept, or the first big idea of this chapter, that in order to change an object's momentum, you have to put an impulse on the object. Okay, so if we look at the problem then here, while standing in the driveway of a friend's house, they kick an 8-kilogram skateboard at you with a velocity of negative 10 meters per second. You put a force of 300 newtons back on it for 0.46 seconds. How fast will the skateboard be going, and in what direction? So if I draw a picture, you're maybe standing here. There's a skateboard here that your friend kicks towards you with a velocity of that negative 10 meters per second. Negative, remember, it's going to the left. And then you put a force back on it that is in the positive direction, 10 newtons that way. So what is going to be the new velocity of that skateboard? So I'm going to take this equation that we have, this I equals Ft equals mvf minus mvi equals delta p, and I have 4 different things that are all equal to each other, but I'm only going to use 2 of them, the 2 that fit the variables that I'm given. So since I'm given an 8-kilogram mass, it looks like I'm going to be using this section of it, right? Mass times velocity, mass times velocity. So I could plug in my 8, plug in my 8. They kick it towards you with a velocity of negative 10. So here's my initial velocity. You put a force of 300 newtons back for 0.46. So it looks like I'm going to be using this section then. So I don't need to do anything with those 2 end pieces. So then I'm going to take 300 times 0.46 is equal to 8. And I'm looking in the end for how fast will it be going. So 300 times 0.46 is going to be 300 times 0.46 is 138, is equal to 8 VF minus plus 80. So my 2 negatives become a positive. I'm going to subtract the 80 over, and I get 58 equals 8 VF. And then I'm going to divide both sides by 8, and I get a final velocity of 7.25 meters per second. So you didn't just stop the skateboard, you turn the skateboard's velocity around, so now it's heading back to your friend with a velocity of 7.25. And we know it's going the other way because we have that positive value there. Now, the second major idea in this chapter is really the conservation of momentum. And this is a conservation law, just like the conservation of mass, the conservation of charge. We have the conservation of momentum that says momentum cannot be created or destroyed. And it's one of the fundamental laws of physics that lasts no matter what we're looking at, whether it's quantum physics or whether it's Newtonian physics, big physics, little physics, we're dealing with the conservation of momentum. And that conservation law says that the momentum in has to equal the momentum out. So if I have an object that is coming and hitting another object, this is going to be my before picture, then their momentum before, momentum of A, the initial, plus momentum of B, the initial, so I'm going to call this B and this A, then this is going to be my after picture, A and B. And their momentum, A final plus momentum B final, they have to be equal. Okay, now it looks a lot more complicated than it is. So let's do a sample, and I think that'll help a little bit with this. So we have a tennis ball that is going to collide with a tennis racket. Okay, so let's just say here's my racket. Here's the tennis ball. This is going to be my before picture. Then I'm going to have my racket and the tennis ball. This is going to be my after picture. So the mass of the tennis ball is 0.15, and it has an initial velocity of -19. And then it collides with a 2 kilogram. So this is 2 and 2. Those two masses are the same. And that racket is moving with a velocity of 9 meters per second. So notice that the racket is going this way because it's positive. The tennis ball is going to the left because it's negative. And then we have to know one of these velocities. So if the velocity of the tennis ball after the collision is a positive 25 meters per second, then we want to know what's the velocity of the racket going to be. So remember, this is going to be a conservation law. The momentum in, mass times velocity plus mass times velocity of each of these guys has to equal the momentum out, mass times velocity plus mass times velocity. And if you set the picture up just like this, where we have our 4 objects, the before and the after, it'll help a lot. So we have the 2 times the 9, the mass times the velocity, plus the 0.15 times the -19, plus or equals 2 times the velocity we're looking for, plus 0.15 times the velocity 25. And now I have one equation with only one unknown, so I can solve for that velocity. So 2 times 9 is going to be 18. 0.15 times a -19 is going to be a -2.85 equals 2v plus 3.75. Now, again, don't make the mistake that a lot of students do where they add the 2 and the 3.75 because this term has a variable, this one doesn't. You cannot do that. So add these two together, subtract the 375 to the other side, and then divide both sides by 2. And you should end up with the racket having a velocity of 5.7 meters per second, which tells you that the racket is still moving forward, which makes sense because it would be kind of weird if you hit the ball and your racket bounced backwards, but your ball kept going, turned around and went the other way. You would need to work on your follow through with that. Okay, so major ideas is you have this conservation of momentum, that the momentum in equals the momentum out, and it's when you're dealing with 2 objects. And then you have this momentum impulse law that is the force times time equals mass times velocity minus mass times velocity, and it's when you're dealing with 1 object. So I hope that helps, and that is momentum in a nutshell.